Are your loops getting complicated, hard to read, sluggish? Today we're going to talk about some advanced looping methods that will help to eliminate some of those problems. It'll help your code to be cleaner, much more straightforward, and your loops will run quicker. Hey everybody, I'm Chris Gambill, and with 25 years of experience in the data realm, I'm here to break down complicated concepts into easy understandable chunks. So follow me as we start to break down advanced Python looping methods. So we're going to start with list comprehensions. That's a big word that basically means that you're compressing your loop down to one line of code, and the Python script is going to process the whole loop in one step. It's kind of like taking a bag of M&Ms, dumping them out, and automatically sorting all the orange ones into one pile. Peanut butter M&Ms for me. All right, let's take a look at our first example. So first, we have our numbers list. 1, 2, 3, 4, and 5. Next, we're initiating a new list because we're going to first take a look at the normal for loop. So initiating our new list called sq2, and we're going to say for num in numbers, sq2.append, which appends this result into the existing list, and then num times num, which is simply squaring the result. So it's going to square 1, square 2, square 3, square 4, and square 5, add it to our new list called sq2. Then we're going to print sq2. Next, we're going to look at the list comprehension. So the list comprehension is going to be squared, which is our new list for the list comprehension. We're going to say very similarly to what our previous for statement was, we have for num in numbers as the second half of this list comprehension, and the first part is the actual calculation. So very similar to the concept of a for loop, but a little bit backwards, right? The first piece of your list comprehension is going to have whatever calculation or whatever you were going to do in your for loop, followed by the actual loop itself. So for num in numbers. Then we're going to print that list comprehension. Let's run that and see what we get. You'll see that very quickly the code comes back for both. Very simple loop either way, but you'll see that it is simpler and much more efficient, cleaner code by using the list comprehension. First, let's do this with our normal for loop. So for num in numbers and with our if criteria, and then we're going to append that number to our new list, sq2, if that number is divisible by 2. So if it's an even number, it's going to append it to the list. If it's not, it's going to move on to the next item in the loop. Then we're going to print our new list. Next, we're looking at creating a new list called evens, and we're going to say for num in numbers, and then with our if criteria, again, if the number is divisible by 2, then it's going to add that number to the list, but this time it's all in one line, much simpler to read, and then we're going to print it. Let's look at see what happens when we run the code. You'll see that we get the same result either way, but the list comprehension with our criteria is much simpler to read, all in one line, much more straightforward. Let's move on to a new example. All right, let's look at zip and enumerate. First, we'll take a look at zip. Imagine you have a bag of gifts, and you're going to give each gift to a different friend. Zip would take your gifts, immediately pair them with a friend, but instead of doing it one by one, it's going to zip it together all at once, just like zipping up a jacket. So think of having a button-up jacket versus having a zip-up jacket. The zipper will always win. So in this case, we have 3 names, Alice, Bob, and Charlie, and their associated scores for a test. You'll see that we have for name, comma, score in zip, names, comma, scores. So we have our normal for loop, but in this case, we're going to zip the 2 lists together, keeping in mind that for this to work, you do need the lists to be in the appropriate order that you need them to zip up in. Just like if you have a mismatched zipper, it's not going to quite zip up correctly if it's not in line. Let's run this code and see what we get. You'll see that it quickly returns Alice scored 85, Bob scored 90, and Charlie scored 88. So let me show you a bonus. I'm going to show you how to add your zip list to a data frame. A data frame is a constructed table that you could use through pandas, polars, or PySpark. So basically, you'll take pd.dataframe, you'll add your zipped lists. So in this case, zip names, comma scores. And we're going to add our column headers. So names and scores simply by saying columns equals names, comma scores within square brackets. Obviously all surrounded by our parentheses. Then we're going to print that data frame. DF is normal nomenclature for data frame. We're going to run that, and we'll see that we have what we received before. Alice scored 85, Bob scored 90, and Charlie scored 88. And then we have a table format with names and scores where Alice, Bob, and Charlie have their appropriate scores beside their names. Really cool, really simple. I love Zip. Does a great job of combining lists very quickly, very easy, very efficiently. All right, let's move on to Enumerate. There will be times when you need to identify the index for each of the items in a list. That is what Enumerate does for you. So Enumerate is like the teacher of a class that starts numbering the kids so that they know what order to stand in line. Except Python's a little tricky, and that teacher starts at 0 instead of 1. Let's use the names list and print the index for each of the names in the list. So you'll see that for index comma name in Enumerate, and then the name of our list, which is names, we're going to print the index colon name for each of the items. So let's run that and see what we get. You'll see that we get 0 colon Alice, 1 colon Bob, and 2 colon Charlie for our list. Let's go over one last advanced looping scenario. In this case, we're going to look at a generator expression. So what a generator expression is, imagine you have a list of numbers from 1 to 999,999. That's a big mouthful, a lot of numbers. We want to find the square of each of those numbers, but we don't need all of them right away. So instead of calculating all the squares at once and writing them down, we have a special way to do it. It's like having a magical machine that gives you one square at a time, but at the moment that we ask for it. So we create this magical machine called a generator. When we say, hey generator, give me the next square, it calculates that square, the next number, and tells us what it is. In our code, large numbers is our generator. It knows how to calculate the squares, but it doesn't do it all at once. It waits until we specifically ask for that square. So when we say next large numbers, it calculates the square of the first number, which is 1, and we get 1 as the answer. When we say next large numbers again, it calculates the square of the next number, which is 2, and we get 4 as the answer. This code is like having a cool magical machine that gives us the squares of the numbers without doing all the work up front. Really neat, right? As a bonus, I wanted to throw in an advanced concept that you might see in interviews. I've personally seen this code on several tests. How do you efficiently calculate the sum of two matrices? I don't know if you remember from middle school math. It's been a long time for me, but a matrix is a square set of numbers. The square could be 3 by 3, 5 by 5, or any number of matching dimensions. Sometimes, often, the math problem is going to ask you to add the two matrices together. So, we would do that with a nested loop. A nested loop is similar to a Russian nesting doll, where you'll open the doll and another one will be inside of it, and you'll keep on going and going and going. So that is the same thing as a nested loop. Here, the example of how to do this is first we have two matrices. The first one we have named matrix 1, and you'll see that it's really just a list of lists. So you'll see that we have our square brackets indicating a list, and then we have 3 rows of numbers with square brackets around those, indicating that we have lists nested inside of our list. Then we have matrix 2, where we have a different set of numbers for our second matrix. Next, we have our result matrix. So we're going to say 0 for underscore in range, len, matrix 1, square bracket 0. So let's break that down. So for each item is the underscore piece, in range, len just stands for length, matrix 1, and then 0 is the first row within matrix 1. So what that's going to do is put a 0 for the same number of items that's in the first row of matrix 1. That way we have initiated our matrix for that row. Now, you'll see that we're also saying the same thing for each of the lists within the list. So for underscore in range len matrix 1 without the square brackets on the 0, because we're going to do the same thing for each of the actual lists that are inside of that list, or each one of the rows. Next, we have for I in range len matrix 1. So this is where we're doing it the old way, right? We're looking at it and we have a for loop nested within a for loop. So you'll see the two for loops. Again, we have the range for the length of the matrix, and then we have the range for the length of the row. And then we have our result. So we're going back into our result matrix using I and j for the specific location that we're on while it's doing the loop, and we're adding those two numbers together and adding that number into our result matrix, replacing the 0 with the appropriate number. Now we're going to print sum of matrices. So that's just the phrasing that we're going to print so that we understand what part is printing when we're running the code. So we're going to say for row in result matrix, we're going to print that row. So that's just simply going to print the numbers that got populated in our results matrix for the row, loop into the next row, loop into the third row. Now that you know how to do it the long way, understand that the long way is not what's going to get you your job when you're doing this interview. It's not even probably going to pass the test. What it wants you to do is give you the list comprehension way. It's more efficient, cleaner code, much more maintainable. Let's take a look. All right, so now instead of having to initiate a result matrix with a bunch of zeros, we're actually going to initiate the result matrix with the actual populated answers. So we're going to say, again, matrix 1 plus matrix 2 with that specific location using the I and the j's. And very similar to how we had our nested loop, we're going to say for j in range, the length of matrix 1 row 0, which is the first row within matrix 1. We're going to move to for I in range len matrix 1. Again, the length of the full matrix. So each of the rows in the matrix, which is 3. And then finally, we're going to say sum of matrices with list comprehension. And we're going to say for row in the result matrix, print row. Same code as before, just simply printing it out. Now, let's run our code and see what we get. All right, now I changed the numbers for matrix 2 so that everything doesn't result in 10, so that you can see that it's actually doing something. Let's run that code and you'll see that we get different results. Cool. We covered a ton today. Be sure to save this video so that you could revisit it later, and be sure you go out and practice with these examples. If you want any of the code snippets, be sure to email me. My email address is chris.gambill@gambilldataengineering.com, and let us know in the comments how your practice has gone. For aspiring data engineers out there, I do have a couple of mentoring slots that have opened up. Be sure to email me at chris.gambill@gambilldataengineering.com. If you want to dive deeper into Python, be sure to check out these videos here. If you're interested in diving deeper into SQL, be sure to check out these. And be sure to like and subscribe for more Python, SQL, and data engineering tips and hints as we continue our journey. Until next time, have fun with data.